Welcome back. In the last video, we talked about how to calculate areas to the left of, to the right of, and between z-scores using the graphing calculator. So we would use normal CDF to answer these questions. And based on the z-score that we're interested in, and whether it's less than or equal to, greater than or equal to, or between two z-scores, that determined what we put into the function. Now, instead of using the graphing calculator, there is another way. Maybe you don't have a graphing calculator and you don't really want to use the one that's online. Perfectly okay. I'm going to harken back again to when we talked about binomial probabilities. You didn't have to use the calculator, although for binom CDF you probably should have. There was the binomial probability formula. You could do it by hand, especially if you had something like the probability that x was equal to a certain value. You had like the n choose x, probability of success raised to a power, probability of failure raised to a power, right? And you could do it by hand. The thing about the normal distribution is that the probability model, algebraically, is quite complex. And calculating the areas under the curve, since it's a continuous distribution, would actually involve taking integrals, which it requires calculus. And I'm not assuming anyone in this class is in calculus or has already taken it. So instead of doing it by hand, you'll need to either use the calculator, normal CDF like we did in the last video, or use this. This is in your textbook. So this is table 5. It's in the appendix of the textbook. It's on page A22. And this is going to show you the area to the left of z, no matter what z-score you want, down to the nearest hundredth. Okay, so this table represents the areas to the left of z-scores, given this ones and tenths value, and the hundredths values are the columns. So let's try and figure out the probability that z is less than or equal to negative 1.53. By the way, these 4 examples are the same examples that we did using the calculator. So we should be getting the same results. You can compare between those if you want, if you already have those in your notes. So if we want the probability that z is less than or equal to negative 1.53, and we want to use the table to find that, we're in luck that this is a less than or equal to sign right here, because the table by default is giving us the area to the left, which is what we want. So whether you're using the calculator or the table, your first step in solving this should be to sketch the curve, just like we did last time. So I'm going to do something very dangerous. You still want to draw the curve for each problem, like we did last time. That does not change just because you're using the table. Once you've done that and you see that we're finding the area to the left of negative 1.53, which would be pretty close to what this is in this picture, except z is negative 1.53, you're going to look for that z-score in this table. So this actually is all of the negative z-scores all the way down to negative 3.49. And you shouldn't have to go too much further than that. We'll talk about that in just a sec. But we want negative 1.53, which is the negative 1.5 is going to be right here. That tells you what row you're in. And the 3 in the hundredths place, that tells us what column we're in. So we want the 0.03. So if we go in this row, the negative 1.5 row, and the 0.03 column, we find that that is 0.0630. That is the area to the left of z equals negative 1.53, 0.0630. And that is actually what we did using normal CDF as well. That's what we had on the calculator. Is it actually here? It is 0.0630 to 4 decimal places. Oh, my bad. I actually typed that in wrong. It's 0.0630. And it's really 0.0630. Either way. Okay. And the reason that you record this to 4 decimal places, you can now see it's because that's what this table does. And that's the standard in statistics, is you report areas to 4 decimals. So, again, I'd like to see if you can use this table whether it's this one on your screen, or maybe that's a little small if you want to use the one that's in your textbook, find the probability that z is less than or equal to 2.17. Again, this is still looking for the area to the left, and that's what the table gives us. So you should be able to find 2.17 in your z-score table and find the area that way. One thing before you do that, all these z-scores are negative. The positive z-scores are on the next page. So for a z-score that's positive, you're going to have a lot more area to the left. So I want you to find 2.17 there, find the area, take a sec, pause the video if you need to, come back when you've got it. Okay, 2.17, that's going to be in the 2.1 row and the 0.07 column. I get 0.9850 there. 0.9850, is that what we got on the calculator? Yeah, when we rounded to 4 decimal places, 0.9840. Okay, so you can see as long as you're looking for an area to the left of a z-score, the table, pretty simple to use. Just find the z-score using the correct row and column, and just record the area that's in the table. It gets a little more interesting when you want the probability of z being greater than or equal to a z-score. We can still find this 1.61 z-score in the table. So we go to the 1.6 row, the 0.01 column. That's 0.9463. 0.9463. But if you drew the curve first, if you sketch the curve, or if you look at the one that you sketched on this example in the last video, you saw that this is the area to the right, and that area should be very small, definitely less than 0.5. But this is 0.9463. This is almost the whole curve. Why is this not the answer we want? Because the area to the left is what the table's giving you. It's giving the area to the left of 1.61, which is almost the whole curve. If we want the area to the right, what do we need to do with this probability? Well, if the whole curve, the area under the entire curve is 1, and we want the area to the right, and the area to the left is 0.9463, then the area that we want is 1 minus 0.9463. So that's going to be 1 minus 0.9463, which is 0.0537. 0.0537, is that what we got on the calculator? Yes, 0.0537 when we round that to 4 decimal places. So personally, if I have a graphing calculator handy, either like a real one like this or this virtual one, I would rather use it to calculate these greater than probabilities, because it's so easy to just look up the z-score, report the area in the table, and not even know whether you're right or wrong. Sketching the curve would tip you off that 0.9463 was not right. However, I've seen so many students report the wrong area here when they use the table. And if they had just used normal CDF, I think that the probability of you making a mistake is lower. But some people are just table people. If you want to use a table, great. And by the way, there are tables for the binomial as well. Depending on what n is, the number of successes you're looking at, and what the probability of success is, you can find all those probabilities too. You didn't have to use binom PDF and binom CDF. I just didn't have time to tell you how to read this table, because that would have taken at least a video by itself, if not 2. Back to normal. So if you're looking for a probability that's greater than or equal to a z-score, you'll have to take 1 minus the area from the table. You just have to remember to do that. And if you draw your curve sketch first, you will know whether you need to do that or not, just by making sense of what the value from the table is versus the area in your sketch. You should be able to tell whether that answer should be above or below 0.5. Now for between. If you want the area between two z-scores, On the calculator, it was super easy because lower was the low one, upper was the high one, mean is 0, standard deviation is 1. You can get it in 5 seconds. You can get this probability using the table, but it's going to be a little more effort. You need to calculate the area to the left of both of these using the table. And you can use the area to the left, so we won't have to do 1 minus here anywhere. But the trick for between two z-scores with the table, find the area to the left of the higher one first, the higher z-score. So that'll be the one to the right. This is 0.14. So we want the area to the left of 0.14 first. That's going to be this row and this column. That's 0.5557. Okay, that's the area all to the left of z equals 0.14. Now, that's the area from here all the way to the left forever. But we only want the area starting at negative 2.51. So, if we find out how much area is to the left of negative 2.51, to find the area in between, we can just take the area we found and subtract the area to the left of the lower end. Okay, so we're going to take 0.5557 minus whatever we find for negative 2.51. So that's going to be negative 2.50, and the 0.01 column, that's 0.0060. And that's going to be equal to 0.5497. 0.5497, is that what we got on the calculator? 0.5496. Okay, so the calculator is giving you an exact answer. The table is actually rounding. These don't just go out to 4 decimal places, so they round. So you might get a slightly different answer using the table versus the calculator, but I would count them both correct. I know what the table and the calculator will give for any question that I give you. So either one would be correct. So I wouldn't say it's particularly difficult to even find the area between two z-scores using the table. It takes a little longer. And of course, the first few times you use the table, it's going to take a while. The more examples you do using the table, the faster you'll get. You can probably get to the point where you can almost figure this out as fast as doing it on the calculator. And that could come in handy, because I know some college professors who don't believe in graphing calculators, and they will give you these tables and expect you to do it with just the table. And if you learn how to do it that way, it can only help you. Okay, if nothing else, you can check your work on the calculator with the table, or check your work on the table with the calculator. I think it's a perfect way to use those resources. And again, that table is in your textbook. You have access to that. I will try to remember for the chapter test and for the final exam to link those images so you don't have to go rooting through your textbook to try and find those tables. I will try to remember to do that. If you take those tests and you find that you need the tables and they're not there, let me know and I will get those in there as soon as I can. But you now know how to calculate the areas under the standard normal curve using either the tables or the graphing calculator. You can choose which way you want to do it. I will not tell you which way to use, mostly because I'll never know. Especially since we're virtual, I will never know whether you use the calculator or the table. So you use whichever one you're more comfortable with. I think the best way to do it is to learn it both ways. That way you can check your answers. But no matter which way you use, you should be sketching your curve first so you know what to expect. Is it going to be a high probability? Is it going to be a low probability? I don't want you to just mindlessly push calculator buttons or look at areas in the table. I want you to connect it to what it is you're trying to find. It is the area under the curve for a z-score. So that's it for this section, and there will be a homework assignment on Canvas. Make sure to look there for when that assignment will be due for the 6-2 homework. And you will eventually have a Chapter 6 test and a final exam for this class. And you can look on Canvas for all the information on when those things are. there will be reviews for both of those tests. So make sure you look for that. And if you have any questions on any of this normal distribution stuff or really anything else in the course as you start reviewing, let me know. Shoot me an email and we'll see how we can help you out. I want to make sure that you're solid on these things before you get tested on them. So until next time, have a great day.